Hello, everyone. Welcome to the National Operations Center of Excellence webinar, Road Weather Spotlight Series, Winter Materials Stockpile Technologies. Thanks for being here today. My name is Kyla Elzinga, and I'll moderate today's webinar. The National Operations Center of Excellence, or NOCO, offers a variety of resources to support the transportation systems management and operations community. You can go to NOCO's website at transportationops.org to browse through links for TSMA resources and news. Previous webinar recordings and case studies can be accessed from the NOCO's resources pages. A few logistics for today's webinar. We are recording the webinar, and the recording will be available on NOCO's website. All attendees are encouraged to stay engaged by using the Q&A feature for questions and the chat feature for comments. These are both on the bottom or the top of your screen, depending on your Zoom program orientation. We have a Q&A session at the end of the presentations, so if you have any questions, we encourage you to enter them in the Q&A area as they come to mind at any time. Also, please feel free to enter your name and agency in the chat to say hello to your peers. I'm going to share a quick overview of today's webinar. We have 4 different presentations today. The first will feature Andy Byers from the Indiana Department of Transportation, speaking about the smart LiDAR system. Then we have Abbas Mohammadi with the University of Utah, talking about a volumetric measurement of salt piles using photogrammetry, LiDAR, and depth cameras. Then Tina Greenfield from the Iowa Department of Transportation will share about a handheld LiDAR system. And then Leighann, Heine, and Francis Fletcher with TxDOT will share about Stockpile reports iPhone and fixed cameras at strategic stockpile locations. So with that, I'll introduce our first speaker, Andy Byers from the Indiana Department of Transportation, to start us off. Andy Byers is a statewide materials manager for the state of Indiana. His core responsibilities include assisting the Indiana Department of Transportation's procurement team with contract and quantity purchase agreement renewals, assisting Indiana Department of Transportation's 6 district materials managers with consumable and material-related items, and overseeing manufacturing operations for Indiana Department of Transportation's internal sign shop. Thanks, Andy.
Well, thank you, Kyla, for the invite to present today. So a few years ago, NDOT partnered with Purdue University in a study that examined best practices in salt stockpile monitoring. We are currently installing QB2 LiDAR systems in our salt barns. I will give, and then it is creating a 3D LiDAR point cloud. So each of my materials managers have access to Cradlepoint. They can log in to live imagery of the point cloud images. So this is what you're seeing on the screen currently. That is the location. The yellow lines indicate the zone that the salt is monitored and measured. And then the colors are the different colors of the peaks of that actual salt pile within that zone. So we have 2 zones within a salt barn. We have our occupied and unoccupied zones. So the unoccupied zone, being the zone that's in the yellow cube, that is for stockpiles, and anything in that zone will be monitored and detected by the LiDAR system. Even though the LiDAR system sees everything else, it will not calculate anything outside of that cube and determine it as salt. So any storage of materials or fleet vehicles, front end loaders, or any traffic in the area that's outside of that cube is fine and won't disturb the actual efforts of monitoring the salt pile. But inside that cube, if you were to, I tell my units, you can park a front end loader in there temporarily, but don't keep it in there long term, because the system will pick it up and measure it as part of the salt volume. Again, we have 16 sites online, 16 sites out of 119 currently online, and then moving to continue installations of this LiDAR system. In this snapshot of a live view from our point cloud and Cradlepoint, Each of our barns have a commission number assigned to them. So in the bottom left-hand corner, you can see that there's a commission number of the building that's identified, and then also the actual volume of salt in cubic meters. All right, next slide. Okay, so to dive into the actual sensors a little bit. So again, solid state sensors, meaning there's no moving components within the actual sensors. Therefore, less room for error and issues with the actual sensors themselves. So 4 to 6 sensors per barn or dome. That's legacy buildings, coveralls, high wall and low wall domes. That's our typical salt barns within the state of Indiana. It consists of a sensor, a bracket, and a dust shield. So the sensor itself, a bracket to mount it to the beam, and then a dust shield to protect from dust as much as possible that you can in a salt barn. Each sensor requires a Cat6 cable ran in PVC conduit. So the picture at the top that you see are 2 sensors mounted on a back wall. The picture on the bottom left, there's 2 sensors mounted, 1 beam in. Sometimes we have to, based on the evaluation of the barn, sometimes we have to mount the sensors 1 beam in to be able to capture the back wall of the barn based on the volume of the salt that's anticipated to be in there. The picture in the middle is a 80-foot boom lift. Based on experience, I will say that the LiDAR installations, we have to be able to get the wheels of the boom lift within 30 feet of the back wall in order to extend over the salt to reach the back upper point of the back wall. And then the picture on the bottom right is actually inside a salt dome. We install the sensors in the very peak of the cone of the salt dome. Again, based on experience, you have to have the 80-foot boom lift completely inside the dome, the back tires clearing the header in order for the boom lift to be able to pivot and extend. All right, next slide. Okay, this is images of our network cabinet. So PVC is roughed out into the brine room. So we have our salt barns, and best case scenario, we have brine rooms within the salt barns, which is a relatively safe place to install the network cabinets. So the network cabinet consists of a fully gasketed cabinet, vented fans to exhaust heat. So in the picture in the top left, you can see the bump out on the doors. That's the actual ports to exhaust heat. The picture on the right, what the network switch is connected to, it is a heated backplate. And then also in the box is a network switch, cellular modem, and a NDOT provided cellular card. In the picture in the top left is the box mounted above the network box. That's actually an exterior cellular antenna. We found that it helps to have the antennas mounted inside the brine rooms for extra signal strength. And then since the network cabinets are fully self-contained, the bottom left-hand picture is an actual very small salt barn where there was no safe place inside the barn to install the network cabinet. So we did a exterior installation. All right, next slide. Okay, tracking data. So data is sent to us, to our IoT department, sent directly from the barns to our IoT department in timestamped CSVs. Those CSVs are received every 5 minutes. They are stored in folders labeled as the building commission number. And then, so that's received every 5 minutes. And then once per hour, the data is automatically, the latest data or latest time-stamped CSV is pulled from the folder, converted from cubic meters to US tons, and then posted on our NDOT dashboard. So anyone who has access to our NDOT homepage can click on LiDAR readings from their desk and be able to pull up. This is an actual snip of a live dashboard that we currently have. So anyone anywhere that has access to our homepage can log in and see actual live information. So this dashboard has, it's broken down by district, and then the structure number or commission number of the building, actual barn, and then sub-district, the unit that the salt barn is located at, the actual latest or last timestamp that was pulled, and then the current weight, the current salt weight in US tons, measured, converted over from cubic meters to US tons. And then we monitor our salt chasing the push or front end loader loaded capacity. So they have a comparison of current volume versus the push or front end loader loaded capacity. And then at the very far right, that shows the percentage of how full our barns are based on our push capacity. All right, Kyla, thank you very much.
Great. Thank you so much, Andy. Really appreciate you sharing that information. Next up, we have Abbas Mohammadi. Abbas Mohammadi is a PhD student in civil and environmental engineering at the University of Utah, whose research focuses on applying computer vision, remote sensing, and data-driven methods to infrastructure and transportation challenges. His work combines advanced technologies such as LiDAR, photogrammetry, and machine learning to develop innovative solutions for safer and more efficient infrastructure systems. All right, I'll turn it over to you, Abbas. Thanks so much.
Thank you, Kyla. Thank you for having me. Hi, everyone. I'm excited to share our work with you that on a very practical things, how to measure salt piles the smart way. This was a team effort. You will see the names here. Many hands make this possible. Next slide, please. So here's the problem in plain words. We need to know how much salt we really have, and we need that number often. Because salt is what keeps us safe. If it gets low, we run short in a storm, and if we get high, we tie up money and yard space. Second, the pile is always changing, loads in, loads out, sometimes every hour. So we need a way to update the numbers quickly. And the third is the old ways no longer suffice. Walking the pile with a tape or stick is slow and not safe. Counting buckets is inexact. Climbing or working near loaders at risk. And work often has to stop. So the need is clear, a method that is safe, fast, and accurate that crews can do without shutting the yard down, inside the shed or outside, and that gives a number we can trust and record. Next slide, please. On the slide, we would have a quick look at LiDAR. LiDAR sends out tiny laser pulses and times how long they take to bounce back. If we know that time, we know the distance. It gives us a point cloud. It's very accurate, works indoor, outdoors, doesn't care if the pile looks plain or has little texture. But this gear can be expensive, and you need a steady setup and a short checklist to have a good scan. Next slide, please. The next tech is the depth camera. This tool takes two pictures at once, a normal color photo and a distance picture. Put them together and you get a quick 3D view. There are a few kinds: stereo, structured light, time of flight. It's small, fast, simple. You can walk around the pile and get a rough model in minutes. No tripod, no drone. But the drawback is the range is short, so big piles are hard. And also bright sun or very dim light can confuse the sensor. Next slide, please. The next method is photogrammetry. The idea is simple. We take many overlapping photos or a continuous video of the pile, walking all the way around and a little higher for the top. The computer then matches the pictures and builds a 3D model. It's safe, fast, and is low cost. Next, please. On this project, we used two kinds of LiDAR. First is a phone-based LiDAR with the Polycam app. It's a scanner that's built into near iPhones and iPad Pros. We open the app, walk a slow loop around the pile, and the app builds a quick 3D model. It's easy and fast, but the range is short. This is great for quick checks or when we just need a rough number. Second is a tripod scanner, the iSight 8820 you see here. We set it up on a tripod, scan from one spot, and then move once or twice to see around walls and corner. It takes a little more time on site, but the quality is excellent. So the big picture is phone LiDAR is fast and handy, and the tripod LiDAR gives us the best accuracy. Next, please. For the depth camera, we use the Intel Sense D455. It's a small bar-shaped camera with two eyes, plus a color camera. It plugs into a laptop and gives us a color picture and distance picture at the same time. Next, please. We use normal smartphones, but any recent phone with a good camera works for photogrammetry. You will also see a tall pole. This let us get a few high, safe shots over the pile without climbing. The next slide, please. Thank you. Now let's talk about the drone setup we use. This is a DJI Mavic 3. It gives us a clean view of the top of the pile and the area around it. It's fast, safe, and great for big outdoor piles. It seems to be the most accurate option when we have enough space over the pile, so we chose this one as a ground truth for our analysis. Next slide, please. Also, we use two main software, 3ds Zephyr for developing and creating the 3D point clouds, and the Cloud Compare software for the final volume measurements. Next slide, please. To make sure this works in the real world, we went to 7 UDOT facilities. We picked a mix of sites, some piles inside sheds with one open side or two open sided, and some out in the open that gave us different shapes, size, lighting, like bright sun, shade, and tight corners near walls. Next, please. These images are from the tripod LiDAR at Marie site. The scanner does okay on shape, but it only sees what it can see from each spot. When the pile is tall, part of the backside are hidden. Even with 2 or 3 setups, you can still miss pieces near walls and steep slopes unless you spend more time moving and re-scanning. Also, the gear is not cheap. The unit and software cost a lot, and the setup takes time. Lining up multiple scans is a bit tricky and needs someone with experience to get it right every time. So for our project goal, fast, safe, repeatable checks, this isn't the best fit, and we have to rule out this option. Next, please. These models come from mobile phone LiDAR. On the can you please, these two are videos. Can you please play the videos for each one, for the models? Thank you. On the left, the Salt Lake East, you can see it worked great. The pile was moderate in height, and the phone could see most of the surface. The result is complete and smooth. But on the right, in Draper, the pile was too tall. The phone LiDAR has a short range, so parts on the backside were out of view. Phone LiDAR is not expensive and it's easy to use, but the coverage is limited. So we rule out these two for day-to-day inventory. It's fine for small piles, for quick checks, but not for the routine counts across the different facilities. Next, please. These are the depth camera results at the Marie site. On the left is the depth image, in the middle is the color photo, and on the right, you can see the point cloud we get. You can see the model is thin, spotty, not even a 3D point cloud. Why this happens? Short range, salt surface is light, grainy, and can be shiny. That makes the sensor lose pixels. The lighting is another problem. Sheds have, dark corners and the sensor struggles. The other problem is coverage and occlusions, and also it has a motion sensitivity. Because of these gaps, we can't make a closed surface, so any volume would be a guess. So fixing it also take a lot of manual patching, slow and not repeatable. So this device is also not a good option for day-to-day inventory. Next, please. From now on, you will see the result from photogrammetry method. On the left, the phone-based photogrammetry result, and on the right, drone-based photogrammetry result. Both looks complete. We see the top, sides, the floor near the walls, the surface is smooth, not spotty, and the shape match what we saw on site. Why this works well? We get full coverage, and also the photos grab lots of details. Next, please. Here's just another example of the chip pile outside the shed in Mount Pleasant. Next, please. Is another example of also chip pile in Selena. Phone base on the left and drone base on the right, obviously. Next, please. Here's the result in Marie site, but here's the real lesson learned. At Marie, our photo model missed the very top of the pile, as you can see at the left image. You can see that a small flat spot where the model didn't close. This can happen to any crew, so let me show and tell you how to prevent it and how to fix it. To prevent it, we have to do a second high pass, use the pole and tilt the camera down at the crest. Also take a few oblique shots from each corner so the top is seen from different angles. Next, please. And to fix it, we can easily use the Cloud Compare software, draw a small outline around the gap at the crest, and use the patch tool to cap the hole so the pile is a closed shape. And with those extra shots or a quick patch, you get a complete reliable volume from the phone-based photogrammetry. Next, please. After developing the model in the 3D FSFL, we exported into Cloud Compare software, which you can see the result of volume measurement on the right. It's a very quick and safe routine we use every time. We just set the floor, trim the model, remove anything if we got any stray items or anything below the floor, and close the gaps and just run the volume, and we record the number in cubic foot or cubic yards. Next, please. We can easily do the same for the drone-based photogrammetry. Next, please. And here's what the numbers look like at the Draper site. That's difference of 11 cubic yards. If you divide 11 by 708, you get about 1.6%. In plain words, the foam method is within 1 to 2% of the drone. So that's a good reliable method for day-to-day inventory. Next, please. At the Twila site, we also work with 5C strategy. They have fixed LiDAR sensor on the roof. I think something like what Andy told us before. The system scans the pile on its own and sends the volume to a web portal, no crew time once it's set up. And on the left is our phone photo model. On the right is the drone model, both looks complete. And how the fixed system works is we take one bare floor baseline, then the roof sensor scan on a schedule and compute the change in volume. And if the floor gets regraded or the walls move, they have to do re-baseline. This is great for a busy yard that wants daily or even hourly numbers with almost no on-site work. Next, please. Here are the volume views for the phone-based and drone model photogrammetry. Next, please. And here are the numbers. Phone photogrammetry, drone photogrammetry, and 5C fixed LiDAR. The phone result was higher than the drone by about 9%, and the fixed LiDAR matched the drone very closely. Next, please. Here are our results across 7 sites. The phone method stays very close to drone, about 1.5 to 6% off, with an average about 3.8. Phone photogrammetry gives trustworthy volume for daily use, fast, safe, and cheap. If yours wants always on tracking, probably adding fixed LiDAR would be the best option. Next, please. Here is a time cost story. The phone photogrammetry time about 5 minutes to take photos, 20 minutes to process. Cost is almost cheap, a camera pole and a software license. The drone is the next, take about 50 minutes to fly, 20 minutes to process. And cost is the drone plus the software license. And it would be the best for using outside when you want super clean top coverage. And the next one is fixed roof-mounted LiDAR. The crew time after setup is basically 0. The system scans on its own and calculates the volume. The processing is automatic. Numbers go to a web portal. And cost is higher upfront, hardware plus a service fee probably. It makes sense at busy sites that need daily or hourly numbers. So the plan is probably simple. Use phone photos for routine, very quick checks. Add drone for big outdoor piles, and use fixed LiDAR at a few key sites where you want always on inventory with almost no crew time. Next, please. Yes, to wrap up, photogrammetry, probably the quickest for big busy sites. Fixed LiDAR, and third is we don't use tripod LiDAR or phone LiDAR for routine checks. Tripod is costly, slow. Phone LiDAR miss tall pile backs. And the depth camera didn't do well on the big salt piles. And standards SOP for the photogrammetry is like, capture photos with overlap, enclosure to modeling, do some quality control check, and just run the volume. Train crews once and track the results always. Thank you.
All right, thank you so much, Abbas. I thought that was really interesting. I thought the images were really handy to see that comparison. So thanks so much for presenting. All right, next up we have Tina Greenfield with the Iowa Department of Transportation. She is the road weather coordinator. She has spent the last 21 years in the winter operations team, helping with winter maintenance research, contracts, data systems, performance measurement, and business analytics. All right, thanks, Tina. Go ahead.
Thanks, Kyla. Thanks, everyone. I'm going to talk a little bit about what we use in Iowa. Going to the next slide, please. So I'm going to start out with material tracking tools that we use to make sure that our salt numbers even stay within the bounds and don't necessarily need any kind of special monitoring. And then we'll go into the monitoring itself, how we do the scanning, and then how the scan results turn out. So next slide, please. So I'm going to start here with the tracking tools because at Iowa DOT, we track all the salt that goes into our sheds through purchases, whatnot. We track sales to entities. We track when material is used in brine making or out on the road. So we have basically a stockpile inventory that we manage, and that should be just like your checkbook. It should show what's actually happening, but sometimes things kind of get out of whack. So the first line of business is to make sure that we can get this bookkeeping managed the best that we can. So we start with tracking tools to make sure that we can catch any errors in that bookkeeping before it blows into a big inventory problem. And we start with visualizations that are easy to kind of find those errors, that give some kind of context to the numbers that you're seeing, and help find any particular errors in our accounting, so to speak, before they get bad. So go on to the next slide here a little bit. This is an example of what we call our salt book, our salt ledger. It's all of the ins and outs that happen at a particular garage. So if someone is faced with an issue with their salt inventory, or they're looking at the shed, they're looking at what's on the resource management system, and it's not lining up, they can go to this system and they can get an accounting of every single in and out of that shed that has been logged since the beginning of the year. And they can even back up to previous years. So like in this case here, there's an entry of 0.0014 tons of salt. And you can sit and think, well, did they really put one shovel full of salt into that function 682, which is aggregate, or basically salt sand mixing? I kind of doubt it. So this is a way that you can kind of look through and say, oh, maybe that number should be something else, and maybe that is part of the error difference. Go on to the next slide, please. And then another tool that we use is targets. So we have a method that we can kind of compute an expected target salt use, because sometimes finding an error is kind of difficult. 2.5 tons, 25 tons, and 52 tons, which are common ways that one can maybe typo or mess up a number when they're entering something, can't all be realistic. It's just all based on the context of what was happening that day, who knows? So this system helps us kind of find the needle in the haystack amongst numbers that might look reasonable, but are out of the context of that day. And so what it does is say, we would have expected that they use something more like the 25 instead of the 52. And you can look at these big jumps and go, wait a second, what happened this day? Even when it was a number that could very easily be overlooked because, out of context, it could be taken as reasonable. Next slide, please. So if all of our little checks and balances don't result in anything that straightens things out on paper, we do have the ability to do salt adjustments and salt shed scans. And we opt for a handheld LiDAR unit. Go on to the next slide. This particular unit is our second unit. We've been doing these LiDAR scans on our salt piles for 10 years now. We have a Zeb Horizon, which is a slight upgrade from the unit that we started out with, which was one of the original Zeb units. The Zeb Horizon has a 100-meter range, a 3-millimeter accuracy, and can spread out 300 laser points in a second. The units are shown on the top of the screen there. Held in one hand, basically, you just walk the pile. The brains of the system are in that over-the-shoulder black thing there. That's where all of the logging happens. And you just basically walk a loop around the pile and collect the scan. And then a very important part of our scanning process is portable lab scale and a Walmart bucket. And that's important because, go on to the next slide, please. The process at Iowa involves taking a density sample at each shed. And in fact, sometimes we take a couple. You can visually tell the difference between certain loads of salt. You know, sometimes part of the shed is loaded with salt from a different company, or maybe it was delivered at a different time. And the salt has variety in its weight, its gradation. Some salt is very large and chunky and has a lot of air voids. Some salt is very fine and has a very densely packed matrix to it. So we try to take a sample or two, depending. We boot up the scanner. We take a walk around the pile in a loop type shape if possible, because as we saw on the previous presentations, the scanner has to be able to see in order to measure. If it can't see it, it can't measure it. So we try to get the scanner up along the sides and try to get visibility by raising the scanner or something like that, so that we can get down in any corners of the shed that might be, you know, off the edge of a slope a little bit, basically so that the scanner can see all of the salt area. We shut down the scanner or go and do another one. It takes us about 10 minutes to boot the scanner and run a scan on the shed. The scanning process is actually by far the quickest part of the whole thing. Go on to the next slide, please. And once we have taken the scan, we go back to our office, and this is what we get. Unlike some of the other systems that you've seen, ours, of course, is a handheld unit. It's not trained on any one garage or any one shed. We have 200 and some salt buildings in the state of Iowa that we manage. So it's up to us to take basically a raw scan of everything and trim it down. Next slide, please. So in that previous picture, you saw the dome. And of course, we're only interested in the salt that's in it. So we get this 3D rendering of the entire environment that scanner was exposed to. And we trim away the stuff that's not salt. So any part of the building, if you had any curious bystanders around while you were taking the measurement, they all need to be basically cleared out of the sample before we can analyze it. And for that, we use a quick train modeler. So after we have the scan trimmed, then now we can calculate the volume underneath the salt profile to the floor level. And this is where we use that salt sample to estimate our density. If you take a really close look at the picture that's on the top right, you can see that the scan itself is so detailed that you can even see the footprints of the person who walked up each side of that main peak area. The scans are very, very precise, but it's that salt sample weight that is probably the biggest variable in our scanning procedure. We take the volume of that pile, we use the salt density measurement that we took of that pile or of that particular shed, and we compute the tons out of that. Next slide, please. And so our procedure for an adjustment is that an admin of the resource management system, like me or my coworker Craig, can go in and we can put in that adjustment. We typically only adjust for scans that are within 5% of the difference from record. And again, a lot of that is just because of the differences that you can get in that density measurement. And again, we found that can vary quite a bit, not just shed by shed, but also from different parts of the shed. So since we can only sample what's exposed, we don't really know the density or how it might be compacted down underneath at the bottom of the pile. We kind of have a little bit of a wiggle room so that if it's plus or minus 5% of our recorded amount, we may or may not change it depending upon what the local forces want to do. And then as far as kind of how this is operationalized, we have had all of our sheds scanned with a LiDAR unit, but we don't scan them all the time. We tend to scan on request. So when when people notice that something's not quite right and they're not real sure, they're looking at their records, they're looking at their salt pile, and they don't think it lines up, that's when we are called in and we'll do a scan. Some garages also choose to scan every year just as part of housekeeping, but most of the time it's as requested unless we're chasing a very particular problem at a site. Next slide, please. So summary of my presentation is, first line of our defense is making sure that our systems for recording salt use and receiving salt use are have checks on them so that we can catch errors before they grow. We also use visualizations to help things that maybe have found their way into the recorded system, but maybe need a little bit of looking into just because they look suspect. And then, of course, if we can't figure out the problem on paper, then we have chosen the handheld LiDAR system because we have one LiDAR system and we have 250 buildings or so. So that allows us to buy one unit and then service all of our locations. We've also shared this LiDAR unit with other offices within the DOT. Our environmental unit has used it on many, many occasions. Our bridge folks have as well. Anytime we need to get basically a measurement of what a shape looks like, we can use it. So we've used it for our own salt stockpile. We used it for aggregate. We've used it for archaeological sites next to construction. We've used it for bulk material, and just about anything at the DOT, we can share that around. The scan time is very short. The longer part of the ordeal is just traveling to and from a site. And then the kind of in between is that there's about a half an hour of work wrapped up into the scan processing. We've been satisfied with the results, and it's been great for settling the amount disputes, especially when you've got an uneven pile that's really hard to estimate, or it's a situation where you really don't want to trust the trained eye, so to speak. So that's all I have to say about our system here. I'll be glad to take questions in the question and answer box. And Kyla, back to you.
Great. Thanks so much, Tina. Really appreciate your presentation. Yeah, again, great graphics, really interesting to see about something you're tracking too. So appreciate that. And if you have any questions, so if you're in the audience and have questions for any of our presenters, feel free to put those in the chat or in the Q&A box. We'll get to those questions after our last presentation here from TxDOT. So I'll introduce Francis and Leighann here. So Leighann Heine is a Texas Department of Transportation State Operations Liaison and Texas's ESF1 for transportation. She manages all hazard, emergency, and weather-related events statewide and has been with TxDOT for 12 years, including 7 years with logistics support operations, which included disaster field response. She was the Stockpile Reports Administrator for several years and developed and facilitated Stockpile Reports training. And we have Francis Fletcher, who is a Support Services Division Materials Management Section Director and has spent 19 years with TxDOT, with the last 9 years being involved with emergency logistics support operations, including hurricanes, winter weather, tornadoes, wildfires, and floods. So now I will turn it over to Leighann. Thanks so much.
Hey, good afternoon, and thank you for inviting TxDOT. We appreciate the invite and are glad we're here. Next slide, please. I'll start off, I'm just going to do a quick history on the how and why TxDOT initiated our strategic salt shed program. One of the biggest reasons is we have a lot of roads in Texas to maintain during winter weather. The little over 200,000 main lanes, 56,000 bridges statewide, and 36,000 of those are on system for TxDOT. Additionally, we have 28 international bridges that are open up between Texas and Mexico that are essential to our national and international supply chain. So it's critical that we keep all the connectors in our interstates open. Next slide, please. We have 25 districts statewide that maintain roadways, 254 counties, and we all face challenges: heavy snowfall, ice conditions, steep inclines, same things everybody else does, and a lot of flyovers. Next slide. So a little history. February 2021, back-to-back massive storms. We had Uri and Viola. Uri is still considered the costliest U.S. winter storm to date, a little over $25 billion. The majority of Texas faced single-digit temperatures for days, and it also hit Mexico. You'd think down at the south is warm weather, but my permanent home is at the coast, and I lost all of my water pipes. Record lows, snow, ice, resulting in a lot of our highways and our roadways being impassable. The storm also resulted in over 400 related deaths and made us really think about our system. Next, please. Just a little oversight, kind of because we are large, a lot of different terrain. Those some of the challenges we face with winter weather are rolling hills out in central Texas. Ice is a big issue here with our trees, which cause additional challenges on our roadways. And then our metros are known for their interchange flyovers. Pictured, that's our Dallas flyover, the High Five. It's 120 foot. And San Antonio just finished up theirs 128 foot, which is the tallest in Texas, back in August. Next, please. So you can see the challenges that we faced. And with the back-to-back storms, we have 25 districts, and they do all maintain their stockpile material to meet their own specific needs. But back-to-back storms made us realize we also need some additional reserves. So especially up north where our snow and ice are common. So we looked to get strategic stockpiles placed, reserves across. And Materials Management Director Francis Fletcher is going to cover the specifics on that program. Francis?
Good afternoon, everyone. Yes, my name's Francis Fletcher. And again, I do kind of help oversee these strategically placed salt sheds. If you go to the next slide, please. This particular shed, as you can see, is one of our standard sheds. It's about 30 by 50. And we, if you'll go to the next slide, we placed 9 of these strategic salt sheds across the state. Originally, they were mainly in the northern part of the state, as you can see by the stars, because these are the areas that were prone to winter weather for us. But after 2021, we learned, like Leighann said, a valuable lesson that we can be impacted statewide. So these 9 strategic salt sheds were placed. The salt in them is reserved for strategic purposes. Each of those 254 counties, 25 districts that Leighann mentioned, they maintain and stock their own salt supply and brine. And we do monitor that through this application we're going to talk about. So like I said, most of the sheds are 30 by 50 or 60, with the exception of one. If you'll go to the next slide, this shed is in Happy. It was the first shed that we implemented this process. We have cameras that are mounted in the rafters. They're basically an iPhone with a stockpile application downloaded to the phone. They're within a protective case that protects them from the salt, the weather, and things like that. And with this technology, we can look at various times of, we can change the amount of times we want to look at. We can track it daily. I can get a real-time measurement. But the main thing was, as Tina mentioned, for Iowa, these sheds are strategically placed, and they're not always near one of our facilities. They're along the interstates or right away. And so with this technology, we can get these measurements quickly. We don't have to travel out there. It cuts down on manpower, and we can better have a better understanding of what we have on the ground. It gives us a visibility that we didn't have when we were having to rely on someone to actually go out and physically take a measurement or lay eyes on it. These strategic sheds, they're a long ways from anywhere, but when you need them there, you need them there. So they are strategically placed. If you'll go to the next slide. So in 2024, we had an audit that highlighted discrepancies in the way we were accounting for our inventory quantities of bulk material, not just salt, but all aggregates. Prior to this, like I stated, we were relying on someone to physically go out, do a manual measurement. I called it a guesstimate because there was a lot of human error involved. There was no real accountability or visibility as to what was actually on the ground. So if you'll go to the next slide. So Stockpile Reports was the application that we selected to be implemented statewide as the system of record for measuring and documenting our bulk inventory. It's currently the only approved method for our end users to use within TxDOT. We've been utilizing this application since about 2015. And even if an end user can't do the walk around the pile or the dome to obtain the measurement, they still have to enter information into that app so that there's accountability and visibility. Roadway material accounts for a significant portion of our budget, and it is just critical that we're able to be accountable and as accurate as possible with it. Next slide. So currently, cones are used with the application and the iPhone. We did look at various options. We looked at LiDAR, we looked at GeoTab, I think that's what it was called. But all of those processes took special training, special equipment, which is not cheap. And it took time to set the markers and so forth. So I'm very interested in the LiDAR that was described earlier. Looks like it has simplified some since we originally looked at it. But again, this application is really simple. Two cones, an iPhone, and you download the application. It was the most reasonable for choice for us at the time because we have over 1,000 users statewide. We obtain over 20,000 measurements annually. And with this application, again, there's no need for special equipment. We are actually in the final stages of a major upgrade to the application, which is going to eliminate the cones. Hope to have that implemented by the first of the year. And it will give us a measurement in less than 2 minutes. And so while you're still on site, if you get that measurement, you can tell that, if you think it's accurate or you need to remeasure it or whatever you may need to do. We do have the capability of using drones with this application, but we've limited that to only a couple of administrative users on my team due to the availability of the drones, the logistics, and also some legal implications. So while drone availability is an option, it's not utilized heavily at this time. Next slide, please. So this is a snippet of the report. It does give us the measurement in cubic yards, which is what we prefer. You can request to have it in tons as well. But as our material is consumed, we we issue it out of our system in cubic yards in the sections because we don't have a way to easily measure it across the state. So we do use cubic yards statewide. The application will give you a report that gives you a 3D dimensional look. You can rotate it. It will show you areas that may have limited accuracy, as you can see with the red in this application. So maybe an area needs to be cleaned up or pushed up, things like that. We also have access to the reports on a web portal. It gives us the most recent on-hand measurements as well as historical data. So you can use that historical data for forecasting and just numerous different uses that we use that for. Next slide, please. We also have a dashboard that we utilize for oversight. It helps us to understand if there's an area or an individual that's struggling with the application that may need some instructional needs. We can see what's on the ground though quickly and easily. That's the main thing. It's important during winter weather events, but we utilize this application heavily for our daily workload and planning, such as seal coat operations, patching operations, and other routine functions. Next slide. I believe that's it. Thank you for your time. Happy to answer any questions or hear any comments.
Great. Thank you, Francis and Leighann. Thanks everyone for presenting. We have some time now for Q&A, so if you have any questions, feel free to put those in the Q&A box, or you can just pop them in the chat and we can get to those. It looks like we did have one from Matthew that Tina answered about kind of the timing of their LiDAR checking. So thanks, Tina, for answering that one there. I do have one kind of general question for panelists as everyone else thinks of questions. It was really interesting, to hear some of the newer technologies that you all are using and implementing. So I have a question, and this could be either on the measuring side or maybe the tracking side is, what advice would you give to agencies who are considering implementing some of these newer technologies, with the LiDAR, the iPhone measurements, things you figured out along the way or like hiccups you had to overcome, just kind of like one piece of advice or a thing you didn't know going in. And that's for anybody, anyone who wants to jump in on that.
So I have a word of advice that I've learned going along the way. So some of our salt barns are being upgraded. So as you get a new structure built, that is the best time to install LiDAR systems with an empty floor so that you can actually get the lift in to where you need it for our systems. And we now have our facilities departments actually pre-run some of the conduit. So our existing buildings, we have to start from scratch on day one, running the conduit, pulling the wires, all of that. So any pre-ran conduit on new structures will definitely cut down the time. Currently, it takes 2 days to bring a facility online. Day one is all installing the network box, running the conduit, pulling wires. Day two in the morning is usually finishing up from day one. We can bring a site online by noon, and then in the afternoon, our IoT brings it online on the dashboard.
Great. Thanks, Andy. Other pieces of advice or thoughts on the real process?
Yeah, this is Tina from IODOT. One of the pieces of advice are things that you might expect, at least, is with any new technology like, iPhone measuring, or this LiDAR stuff, it's going to be weird and different, and you might have some convincing to do, especially when you show up and you scan somebody's shed and it's a lot different from what they think is in there based on what they've always kind of had their calibrated eye set to. And so one of the things that has helped that is Doing scans of known amounts. So if you had a shed that was emptied to the floor and they filled it up with orders, and they have all the scale tickets and everything like that, doing some demonstration scans or something that you can, kind of prove to people that the system actually does work. It comes up with a number that makes sense, things like that really help build confidence in these things, particularly if you're coming into an area that's your results are a lot different from what people were thinking.
Great, thanks, Tina. Any other thoughts? I do see we have a couple more questions here. So it looks like Francis just answered one. Question for Texas DOT. Do you mount iPhones in your salt sheds or use handheld iPhones? Francis says they're a handheld iPhone, which are especially encased by the vendor to prevent moisture and condensation. They have been installed 3 years and we've not had any issues. Okay, great. Francis, is there anything else you want to expand on that verbally? Okay. Okay.
No, like I said, we've had them installed for 3 years and we haven't had any issues or problems with them. Going back to what Andy was stating, it is definitely easier to install them when the sheds are empty and run that conduit. There does need to be a power source to keep those iPhones charged up. They will stay charged for 2 to 3 days if the power fails. So we do have, we have power at all the sheds. We do have one that is very remotely located that we actually use solar, have a solar device there to power those. But no, that.
Great.
When starting the program, how did you develop the scope required? So we started thinking about what we needed as far as reporting, the locations, and I'd be happy to share some information with you offline about that because it was quite a process.
Great. All right. Any other questions? Great. Any kind of closing thoughts from any of our panelists? Other things you want to leave with the audience before we wrap up? Okay. All right. Well, if you have any questions, you've got 2 more minutes to pop them in quick. I'll just share a few more things on our end to wrap up here, but we just want to thank everyone again for their time. So we have another of these road weather spotlight webinars coming up in January. So that will be January 7th on avalanche forecast mitigation and research. So we could put a link for that in the chat. That's another webinar again in the same series on road weather. And then just wanted to share a few, other resources. At the beginning, I mentioned the National Operations Center of Excellence website. A lot of great resources there on all sorts of operations topics, as well as the recordings for some of the past webinars in the same road weather spotlight series. So just want to let everyone know about those opportunities. I think that's it on our end. Just want to say a big thanks again to the panelists, to Andy, Abbas, Tina, Leighann, and Francis. Just great content today. And be on the lookout for this recording, which will be up on that website. All right. Well, thanks, everyone. I hope you have a great day. Big thanks again to our presenters. Have a good one. Thanks, everyone.